Welcome. Let us talk about clustering. And in this particular discussion, as we know, we are doing data mining, and in data mining, the most important is learning, because we are trying to discover knowledge from the data. But there are unsupervised learning. That means we don't see what we learn, and that is the kind of problem we are talking about is clustering. So what is a clustering? You can see here, you're trying to find a group of objects. Look at this picture. We have three different set of objects here, and we are trying to find kind of similarity between them and then try to group them. But when we are actually finding similarity and grouping them, we really don't see them, but we try to do some calculation based on which we actually can group them. And this particular problem is also called unsupervised learning, sometimes called classification by statisticians, and sorting by psychologists, and segmentation by people in marketing. So what happens here, you can see in the blue box, interclass distance are maximized. So we are trying to measure a kind of distance to cluster. There is a huge practical application of this particular problem, because in data mining, clustering is used widely to do like market segmentation. You're talking about document separation or document clustering. We are talking about clustering and in different region, different geographic regions. So we have so many different types of application of clustering. Take a look at this. What is a natural grouping among these objects? These are actually, varieties objects are mixed together, but when you look at their properties, based on their certain properties, you actually group them into four. Clustering is subjective, as you see. So what happens, you actually see Simpson family, school employees, and then you have uh, you know you have firmates, and you have mates. So all are actually now classified but clustered based on their certain attributes, certain features. So you can understand similarity is subjective. You look at this two figure, you have a some kind of similarity measure happens in your brain to find certain commonalities among the objects. So there are intuitions behind desirable distance measure properties. For example, we try to say distance of AB and is equal to distance of BA. That's actually symmetry. But when we say distance of AA is actually constancy of self-similarity, because it's always zero, and then you have a positive separation and triangular inequality kind of intuitions behind desirable. So application of cluster analysis, first of all, you have a different types of understanding of groups. So group related to documents for browsing, groups, you know, genes and proteins that have similar functionality, group stocks with similar price, fluctuation, and customers that have similar buying habits and so on. And sometimes summarization, reduce the size of the large data sets. So notion of a cluster can be ambiguous. Why? Because we really do not know how many clusters. It depends on what type of data are we getting. So tell me, how many clusters do you really see? Here we see 6 clusters. You see, on that right hand side, what we see is 4 clusters, because it's very difficult to say. We see 2 clusters, but understanding of cluster is region specific. So that's actually a very important point of the discussion. The types of clustering. A clustering is a set of cluster, of course. An important distinction between hierarchical and partitional set of clusters. Partitioning cluster a division data objects into non-overlapping subset. That means they don't overlap each other. Each data object is exactly one subset. That means partitioning cluster is very clearly separable. Hierarchical cluster is a set of nested cluster organized into a hierarchy of the tree. So you can see here clearly partitioning cluster, very straightforward. Original points and a partitioning cluster. So based on certain characteristics of the data points, we decide that this is a cluster. Hierarchical cluster, on the other hand, you can see that's actually kind of a hierarchy, and you do actually have a cluster, but it's hierarchical cluster. So there are other distinction between set of clusters, exclusive versus non-exclusive. One distinction, characteristics. In a non-exclusive clustering, points may belong to multiple clusters and can represent multiple classes or border points. So what happens is the non-exclusive and the exclusive, you can understand its differentiation is very, very clear. Fuzzy versus non-fuzzy. In fuzzy clustering, a point belongs to every cluster with some weight between 0 and 1. And you have actually weight must be summed to 1. Actually, probabilistic clustering has similar characteristics. And you have a partial versus complete clustering. So types of cluster, you can see well-separated cluster, center-based cluster, contiguous cluster, density-based cluster, and described by an objective function. So there are different types of nature of cluster. There are two types of cluster, well-separated cluster. You can see 3 well-separated cluster. So those data points has a very specific characteristics, and we can separate them that it's actually 3 different clusters. But center-based clusters, you can see a cluster is a set of objects that an object in a cluster is closer to the center of a cluster. That means there is a center of the cluster and something is close to that. That's one we sometimes call center-based cluster. The center of cluster is often centroid. Please remember, centroid means you're talking about the center of a cluster, the average of all points of the cluster, or this is one centroid, or a midpoint, the most representative point of a cluster. Alright, so types of cluster, you can see continuity based cluster. These are different types of continuity based clusters. Types of cluster, density based clusters, right? A cluster is a dense region of object. Well, it's density based cluster. So types of cluster, objective function. Cluster defined by an objective function means you have a function which helps you to determine which one is the cluster. Find cluster that minimize or maximize an objective function. An objective function means you're putting some value, you're getting a calculation done by the function. So enumerate all possible ways of finding those points into the cluster. Example, sum of square of distance of cluster center. So there are clustering algorithms, and 3 algorithms are very, very important, but we discuss more on K-means algorithm. K-means and its variant, hierarchical clustering and density-based clustering. Well, we try to explore all 3 different clustering. So K-means clustering, what happens? K means, that means we have a something value of K, and we are trying to calculate mean, by which we try to cluster. So partitioning, it is actually partitional cluster approach. That means we create data partition. Each cluster is associated with a centroid. There is a center point of the cluster, and each point is assigned to a cluster with a closed centroid, and number of cluster K must be small. That's what I'm saying, that you start with an assumption of K, but you have to trial and error to find out which one is best. And there are different algorithms built into Weka and other, and we see actually what happens in case of Python also. You select a K and then you repeat. From K, you assign different cluster and find out. So that means you need to calculate distance. I'm going to show you that we actually use here Euclidean distance to find the point where it should go, because it is unsupervised learning. You understand, a data point is coming and you're deciding that this data point go to my cluster 1 or cluster 2 or cluster 3 based on certain calculation. Alright, so K-means cluster, what happens? You ask the user how many cluster. Example, K is equal to 1 or K is equal to 2 or K is equal to 3, and then randomly guess 3 cluster point. This is the data points. So randomly guess K cluster center locations, and then each data point finds out which center it is close to, because you are actually now calculating the distance of data points with the center to find out which one is close to whom, and each center finds the centroid of its point its own. Centroid is the average value, because you see K mean average value, and jump there and repeat until terminate. That means all point gets organized close to the close to the centroid, and centroid is the center value of the cluster. So this is actually step 1. You can see we have 3 K1, K2, K3, right? So you understand that this K1, K2, K3 is gradually going to move. Our data point cannot move. Data points are data points. So what happens next? K1, K2 and K3 is moving because it's actually going to find out the average value of the data points across the cluster. And then you can see the value of K is now moved in a different location. So we started with the initial assumption, 3 cluster and then 3 random location, and then gradually moving those clusters. We are again moving, right? K1, K2, K3 is moving, and then finally it come to this point, and then finally what we see that initial centers are often chosen randomly. That is challenge. You have to repeat again to find the right cluster. The centroid is the mean of the points in the cluster. That means whatever data points you have in a cluster, you calculate the mean because it is K-mean. And closeness is measured by Euclidean distance, as I am saying, correlation, etc. And K-means will converge for common similarity measures. And most of the convergence happens in the first of few forms. So evaluating a K-means cluster, most common measure is, how do you evaluate? You measure sum of the squared error. That means you have to measure sum of the squared error. For each point, the error is the distance to the nearest cluster. You know that cluster has a center, but your point is a little far from the center. So the error, actually sum of the squared error, is helping you to understand that how good is the cluster. So to get SSE, we square these errors and sum them. We can show that to minimize SSE, the best updated strategy is used to the center of the cluster. That's what I'm saying. So given 2 cluster, we can choose the one with the smallest error because that is actually a very dense cluster. And one way to reduce sum of the square error is to increase K, the number of cluster. Okay, very good. So we can see 2 different K-means clustering: original point, and then optimal cluster, and then suboptimal cluster. And importance of choosing centroid is very, very important. But if you happen to choose good initial centroid, then you will actually get this after, the iteration takes less. Otherwise, you may take a lot of iteration, but you may not get to the correct results. So it is very important to choose the good centroid location initially, but it is random, trial and error. These are actually some of the examples. I'm showing you 10 cluster examples. These are 10 cluster examples you can see. So pre-processing and post-processing, what happens? In pre-processing, we normalize the data, eliminate the outlier. In post-processing, we eliminate small clusters that may represent outlier, because clustering helps us to know. Clustering is very important. We can actually apply clustering both in case of pre-processing and post-processing of data. Pre-processing, we can actually normalize, eliminate outliers. That's actually in pre-processing. And post-processing, we eliminate a small cluster that may represent outlier and split loose clusters, merge clusters. So clustering got a tremendous use in data pre-processing and post-processing stage. But there is a limitation of K-means. K-mean has a problem when clusters are different size. You have to have a gaze, initial gaze, densities, non-globular shapes. So K-means has problem when the data contains outliers. So these are actually limitations of K-means differing size. You can see you cannot differentiate the cluster. Original points, K-means 3 cluster is very difficult to segregate them. Limitations of differing density, you can understand. And limitation of K-means non-globular shape, because it is like mixed up clusters. Overcoming limitations, one solution is to use many clusters, find out the cluster that we can put together. So these are actually different limitations of overcoming. And this is actually about hierarchical clustering, and you can actually visualize a dendrogram. Dendrogram is very, very important. Take a look. Hierarchically, we can cluster different country flags. Hierarchical cluster sometimes show patterns. It's very important. I skip this part also. So practically, we actually so far the strength, weakness of clustering we have applied, but you know, in every situation, clustering has a tremendous potentiality, and one of the most common is K-means clustering. So I stop here, and I'm sure that we actually focus on K-means clustering for and experiment the different clustering technique in Python. So dbScan is also another form of density based algorithm, but just skip this also. We skip this part. And cluster validity is something we, for supervised classification, we use a variety of measures. How, what are the measures? We remember accuracy, precision, recall we can measure. But for cluster analysis, the analogous situation is how to evaluate the goodness of resulting cluster, but clusters are in the eye of the beholder. So it is very difficult sometimes. So then why do we want to evaluate them? To avoid finding pattern in noise and a lot of other reasons, like compare clustering algorithm, compare two sets of cluster, and so on. Alright, so I just keep this also. You already know that. And final comment is this. Alright, so I hope you keep enjoying the data mining, and it's very, very important.